Hello, Airbus Cockpit Coach here. In this video we're going to look at the braking system of the Airbus A320 in more detail. Standing by one of the main undercarriage of the Airbus A320 as modelled by Phoenix, and you can see various parts of the braking system. Hydraulic lines, over here we've got the actuator side, hydraulic actuator side, which pushes against a pressure plate inside the wheel there. Essentially it's made up of a number of different discs. So we've got through the wheel a number of stator discs which don't move, and a number of rotor discs which move at the same speed as the wheel. And when we apply brake force with our pedals in the cockpit, the hydraulic actuators here push on a pressure plate which squashes all those different plates together inside the wheel. So it's multiple discs essentially. The braking system itself is carbon. Most modern airliners now do have carbon brakes fitted. Many years ago they were steel as a standard. There were some disadvantages of steel, although they were cheaper to replace. They weren't great at dissipating heat, and they're quite heavy as well. They're pretty heavy to have on board the aircraft, so there's a reasonable weight difference between steel brakes and carbon brakes. I think it's in the region of about 300 kilograms, so that's significant impact on overall operations if all your brakes were carbon as opposed to steel. Carbon, very good at losing its heat, and they're very light as well. It's one of the advantages. Obviously, oxidation and carbon isn't great. Obviously, carbon does react with oxygen, especially in wet conditions, or if we have chemical interaction as well with things like de-icing fluid on during the winter from taxiways and the ramp. So they can suffer a bit from that, and that's something we have to keep an eye out for during maintenance checks. You can see here we got the brake pin here. You want to make sure you got some brake, that pin showing on this side. Just make that shows you that you've got enough thickness on the brake pads remaining. Generally we lose, I think on average, about 1 millimeter of brake wear for every 20 landings, or 20 flights I should say. So that's gives you an idea of the wear on these. They are expensive to replace. I think a set of these would cost you in the region of £200,000. They can be replaced on stand here. They can jack the aircraft up. There is a jacking point underneath the undercarriage. They take the wheel off, disconnect these hoses and a few bolts, and away the brake system comes, and they can put a new one on pretty swiftly. That's something we do see on stand quite often. The braking systems on airliners are designed to cope with the worst case scenario of a rejected takeoff. So that's the performance they're required to achieve in terms of maximum takeoff weight at V1 speed on takeoff, full brake being applied in those situations. So that's when you've got huge kinetic energy, and the role of the brake is essentially to convert that kinetic energy into heat. Obviously in those kind of worst case scenarios it would be expected to see smoke and flame. Usually any fire though is located to the brake area itself. Sometimes we can get something like a damaged hydraulic hose which will start spraying some hydraulic fluid onto a hot surface, causing fire or smoke. But the hydraulic systems do have flow valves which will cut off, so it's going to be a limited amount of hydraulic fluid, not the whole system that would empty out into a wheel. So generally speaking, a fire in the wheel area is contained to the wheel area and the brake area. As opposed to steel brakes, carbon brakes wear faster with an increased number of applications of brake. So when we're using the brakes, we want to be using longer, smooth applications to bring speed down than numerous short applications of brake. Different operators will advise pilots on how they want to the braking system to be used in conjunction with sort of fuel saving versus brake wear cost. It would be good practice, however, if you've got a long straight area of taxiway with no air traffic control restrictions, you want to let the aircraft speed up to 30 knots and then provide a smooth brake application which brings that speed back down to around 10 knots, rather than just keep jumping on the brakes to control that speed. With the Neo version of the Airbus A320, they do accelerate on the taxiway on idle thrust more easily than the CEO variant, so again, more braking is required on the Neo. And also, if we have engine anti-ice on, the idle thrust of the engine is higher, and therefore the aircraft will have more forward energy in that situation, which can result in the needing for more brake application. They're just considerations. Carbon brakes wear faster when cold, and they're a little bit more grippy when they're warmed up, so they are more effective in terms of their operation once we're into warmer temperatures. We do have a limit for takeoff of 300 degrees Celsius, so we cannot depart with the brakes being above that temperature. The reason for that is not actually brake performance, it's to do with the risk of hydraulic fire in the wheel well. So if we had a leak when we retract the undercarriage, we don't want any hydraulic fluids in the wheel well coming into contact with hot brake surfaces. So that's the reason for that limit. And the brakes themselves can operate and provide rejective takeoff capability over 600 degrees Celsius. So we still have good performance out of the brakes at high temperatures. There will obviously be a point where the brakes are less effective, but you're talking extreme ranges of heat, and we're unlikely to see that in sort of day-to-day operations. To help us deal with heat, we do have brake fans, you can see here on the side of the wheel itself. So in here we have a little fan. The brake fans are sort of optional extras. Obviously there's a weight penalty to having them fitted, but also when we're wanting to depart and we've been using the brake fans, we do need the temperature of the brakes to be below 150 degrees Celsius, and that's because of where the temperature sensor is located. It's having obviously airflow blown onto it, and the far side of the brake could still be a lot hotter than the temperature sensing side. So there is a 150 degrees Celsius limit in place for us as pilots when using brake fans. But they are useful, and especially if you're doing short turnarounds or long taxis and multiple short sectors, that they start to become more and more useful. They are, however, very noisy. You definitely want ear protection on when you're near them and they're turned on the ramp. For landing, flap setting is a consideration for brake wear. Flaps full, we have lower kinetic energy generally on landing than flaps free, so flaps full is something we want to consider if we have a short runway and a fast turnaround. The optimal is having flaps free, use of idle reverse and auto brake low, but for that you're going to need a long runway. You also want to consider where we are vacating on the runway. Whilst it may say fuel to take an earlier exit, rather than jump on the brakes excessively on touchdown or to make that exit, it may be worth, from a brake wear perspective, taking the next exit. So a number of different things to think about when it comes to operating costs, fuel saving versus brake wear. After a landing, it is normal for the temperature of the brakes to increase and keep increasing for some time. We don't want to put the brake fans on straight away normally. We want to leave it at least 5 minutes ideally, unless we have excessively high temperatures in sort of the region of 500 degrees plus. At that point we'd put the brake fans on immediately. But it would be very rare to experience those kind of temperatures. We do want to turn the brake fans on, however, if we're going to use them before turning on to stand, as they do blow out carbon brake dust, which isn't great for the ground crew. So it's something we'd turn on before getting into the stand itself. So I hope you found that useful. Any questions on that, please drop them in the comments, and please hit the like button and check out the channel memberships. Thanks for watching.